Welcome out there today. So my name is Rakubu. The focus of this lesson will be data representation and the importance of representing data. I hope you're there, you engage and try to work hard, and remember mathematics is about consistency, okay? And don't give up. Let's look at what data look like. But before we do that, I'd like you to think about something. What do I want you to think about is, what do you know about a career in data analysis? Do you know anything in career in data analysis? Yes, we do have data analytics. They work in banks to what? Analyze data. But actually now, we're in the third quarter of the fourth industrial revolution. I mean, even a psychologist needs to analyze data. A sports scientist needs to analyze data. Each and every person needs to analyze data. I mean, the fourth industrial revolution, it's about collaboration between human and machine. It's the world of data, okay? So I'm not sure if you ever thought about that, career in data. And also, what did the government use to decide on the level of lockdown from level 5 to level 1? Do you remember? We had our first case, coronavirus cases, okay? Then from there, they used the moving average by collecting data. I think by the time we had about a moving average of 100, then we went into a national lockdown, okay? Then the collecting of data, it's very crucial for analysis and making decisions. Great, fantastic. So, what does a data analyst do? Why will an insurance company give SIPO a different premium and Bongani a different one? By collecting data. They'll ask you as an insurance company, where do you live? And in that area, it might probably be a high crime, okay? They might charge you high on insurance premium. Or maybe Bongani might be younger, based on the data they've collected as an insurance company, with no experience of driving, and they might charge him a higher premium. So it's important to collect data, okay? So how would you describe data in words? Have you ever thought about that? I mean, data doesn't mean numbers only, okay? I'm not talking about data for a cell phone, okay? There's another data. But the data we're talking about is how many people taller than 2 meters in this country, something like that. That's the kind of data we're talking about, okay? And how many COVID cases we're gonna have at the end of the pandemic. We don't know. That's the kind of data we're talking about, okay? So, under representing of data, we'll talk about histogram. We'll look at stem and leaf diagram. We'll also look at the bar graph and a line graph. After a line graph, a pie chart. Okay, then a frequency table. Okay, then let's look at some of the keywords. What is discrete data and what is continuous data? A discrete data takes a specific value. A discrete data will be like, can I think of something discrete? It might be if I roll a die, I'll get what? 1, 2, 3, 4, or 5, or 6, nothing else. But what about continuous data? Continuous data could be, it can take any specific value. It could be the temperature. Today it could be 30 degrees Celsius. Tomorrow, 35.5. So it can take any value, where discrete is a fixed value, continuous can take any value if in some decimal. That's the difference between continuous and discrete data. Okay, so then now let's look at more keywords. Frequency table and tallies. What is a frequency table? A frequency table, it's a way of grouping data together. Okay. If we look at COVID cases, we might group people with COVID cases who are younger using a frequency table. So, and we can have another group of people older than 60 with COVID. And we can have another group of people older than 70 with COVID positive. There will be a frequency table. And the tally will be how many people with COVID cases between the age of 70 and 80. If it's 100, there will be their tally. Okay. And if I want to know how many people with COVID case between the age of 1 and 5, if they're 100, the tally, that specific value, will be 100. Okay? I hope this makes sense. Frequency and tally. Great, fantastic. Now, we're going to look at, so we look at bar graph, histogram, pie chart. Now we're going to focus on the frequency table. So what do we have here? The following data shows the number of runs scored by an opening batsman during matches at last season. What is happening here is that there was a cricket match, okay? And there was a sportsman who got 42 runs. Another person got 34 runs. Another person got 49 runs, and so on, okay? So this is called raw data, okay? Raw data, just random, all over the place. But we want to group this data using a frequency table so that we can present that, okay? Because if we have numbers like this, it doesn't really mean anything, okay? So how do we draw a frequency table for this ungrouped data? So this is what we're going to have. We have our data there. Now we have to group our runs. Means how many runs between 0 and 19 runs from our set of data from there. So if we count that, how many 0? So let's count them. We have 0, 1 there. I can do a tally, which is 1, 0 there. I'm trying to find numbers between 0 and 19. So I'll represent that with a tally. Let's find another number. I have 5 there. I'll do that. Oh, let me look at another number. Oh, there's 12 there. Cancel. Do I have another number? So what do I see? There's 18. Okay. Then what else? 42 not there, 99. I'm trying to search. Okay. Then let's see if I'm correct. Yes. So what does this mean? We have 4 tallies between 0 and 19. Between 0 and 19, we had 4 runs, score of 19 between 0 and 19. Between 20 and 39, remember this represents 5. This is 5, this is 4, this is 5 plus 3, which is 13. This is 5, this is 4, this is 5 plus 2, and this is 5, and this is 2. How do we do this? This is 1, this is 2, this is 3, this is 4, then number 5, that's how we do it. So this represents 5 in tallies, okay? Then what about frequency? So the frequency, just the total tallies, okay? We just sum the tallies. So for frequency, we're going to have 4 there, 13, 9, 7, 5, and 2. What does this mean? This implies this team, we have 2 runs of between 100 and 119. we also have 9 of between 40 and 59. Okay, this is our tally table. Okay, fantastic. So now let's look at representing more. We'll still go to histogram, bar chart, line graph. Now we want to focus on stem and leaf. Stem and leaf is another way of representing ungrouped data. Okay, how does this work? So a stem and leaf plot is a frequency diagram in which the raw data is displayed together with its frequency. The data is then placed in a suitable group. Okay, let's see now. How does this work? So there we have our data from 29 all the way to 35. There, it's ungrouped. This is what we're going to do. We're going to have a stem, then a leaf. So a stem, it's our tens. Okay? Okay? So think of a stem and a leaf. Okay. What does this mean? So if you look at our digit, the smallest number we have here is 3. That's the smallest number we have, 3. And the highest number we have is, I think, 58. So 0 there, for that 0 implies I can put a single digit number here. Here I can put 11 will fall in there, 20 something will fall in there, 30 something will fall in there, and 40 something will fall in there, and 50 something will fall in there. Let's see how does this work. So we start with the smallest number. So we'll have units this side, 3. This implies we have 3 there. Then let's find a single digit number from our data if we have. We have 5. 5, 3 gone. Then we have 13. Can I see 13? There's 13 there. So this implies this is 13. This is 13. Then we go and we have 14. Where's 14? 14 there. This is 14. 1, 4 means 14. Then another 14. We have another 14. Can I see that? Yes, there. You go, we have 18, 19. Then we go into 20s. So we have our 20 there. This implies it's 20. Then we find 20s. So do we have 21? Do we have 22? So we have 23. We go 24, 28, 28, 29, 31, 32, 35, and we have another 35. We have 42 there, so this is 42. Then we have 42 again, and we have 47. Can you do all of them? Then we have 50 and 56 and 58. Okay, let's go back. Now, this is our stem and leaf. Okay, that makes sense. So we start with the stem and the leaf. The stem is your tens. Okay, that makes sense. So let's say I had 100. So I could put 10 there, and I could put another digit that side. Does that make sense, guys? Okay, great, guys. So I'll see you after the break, and we'll continue with the representation of data together. Welcome back once again. Okay, so we'll continue with our data representation. Now we're going to look at another way of representing data. Okay, so what we're going to look at now is something called the bar graph. Okay. We're going to look at the bar graph. So let's look at this question. The data below shows how the students in grade 7 arrived at school one Monday morning. Okay? So what does it mean? 6 students walk, about 10 use a bus, 7 a bike, and 4 a car. Okay. Then how do we represent this data as a bar graph? Okay, so let's see. So we have our data there. Okay, so we need a Cartesian plane with the x-axis and the y-axis. We're going to put frequency there, and we have walk, bus, bike, and run. Okay? Remember, frequency is, if we go back, what's wrong? I said what? I said run. Oh, Jesus. I said run. Gee. Oh. Oh. From there. Oh, from here. Why does this? Oh. Why is the bad? Erase. Okay. Even frequency. Okay. Okay, let me get my pen. Light blue. Okay. So I start from frequency. Okay. Do I start from, we have our, okay, a Cartesian plane. Okay. How many minutes left? Okay. Okay. Yes. Yes, now we have our Cartesian plane there. So on the y-axis, we have frequency. On the x-axis is walk, bus, bike, and car. Okay. What are you going to do with this? So we have to, for walk, how many students walk? We have 6 students walk. So actually, with your ruler, that's what you do. Because about 6 students walk, okay? Then we have about 10 students use bus. Should be 10. Okay, 10 uses a bus. And how many uses a bike to come to school? So we had 7 use a bike, and 4 use a car. Okay. What do you notice about this bar graph? Okay. So actually what I'm missing is a heading. We need a heading there of the bar graph. I've labeled the x-axis, and the y-axis has been labeled also. And if I look at the bars are equal in length, the distance is the same as the distance is the same as this distance. And there's also gaps in between the bars. Okay. So I hope this makes sense. Okay, it's a straightforward graph to draw, which is our bar chart. Now, we're going to go back. We looked at bar, so we're going to look at the pie chart. Okay. I mean, you might ask yourself, I mean, there's just so many ways to represent data. Why should I know all of them? I mean, some kind of data suitable to have a pie chart, some suitable to have frequency table, and you can see, for example, with the COVID cases, they've been reported using a frequency table with age, how many cases, okay? And sometimes you want to know how many cases in each province. So it's better to have a frequency table also sometimes, okay? So let's look at pie chart. So a pie chart. So let's look at the question. In a survey, people were asked to indicate which one of the 5 musical instruments they played. The information is given in the table. Display the information in a pie chart. So what does this mean? We have musical instrument. We have guitar, about 35, play guitar. Violin, 10. Recorder, we have 15. Drum, 5. And keyboard, 25, play keyboard. And in total, we have 90 people took a part in the survey. Then how do we represent this in a pie chart? So a pie chart, what we have to do is to calculate the angle for each and every instrument. Remember that a pie chart is a circle, and angles around circles add up to what? 360 degrees. Does that make sense? Okay. If we add all the angles inside a circle, it's 360. Okay, great. For a guitar, we have 35. And we have violin 15, recorder, drum, and so on, and the total is 90. So we have to convert 35 into an angle. How do we do that? So for a guitar angle, it would be 35 over 90 times 360, because we know that the angles around a circle add up to 360. So we get 140 for a guitar. For violin angle, it will be 10 over 90 times 360, we get 40 degrees. Recorder, we have 50 over 90, which is the total, over 360, which gives us 60 degrees. Drum angle is 5 over 90, which is there, times 360, angles around the circle equals to 20. The keyboard angle is 25 over 90 times 360, which gives us 100. Okay. Now, how do you check you're correct? What you can do is all these angles, that plus that plus that plus that, should add up to 360 degrees. Okay. Now we have all the angles. Now we have to draw our pie chart. Let's look at our pie chart. So our pie chart, so our angles are 140 for guitar, violin 40, recorder 60, drum 20 degrees, 100. I mean, you'll need a protector, okay? If you don't have one, you can approximate, kind of. We know kind of half a circle is 180, a quarter of a circle, 90, and so forth. So that's what you can try to do by approximating. So what I have here is a guitar, which is 140 there, a violin, keyboard, drum, and recorder. Let's look at the angles. So very important to put the angles. We have 140 for guitar, violin, 40 degrees, recorder, 60, drum, 20 degrees, and 100 degrees for a keyboard. Okay. Now, this is how you represent a pie chart. Okay. So, have you seen a pie chart before? Okay. I mean, you can represent a pie chart by how many male and female in this country, something like that. Okay. You can do that. You have probably seen a pie chart somewhere. Now, let's look at another way of representing data. Okay, so go back. So representing data, we looked at the bar graph, we looked at the pie chart, we looked at the stem and leaf. Now we're going to look at the line graph. Okay. How do we look at the line graph? Okay, let's look at the question. So the data below shows the maximum outside temperature as recorded by a gardener over 5 days period in January. So on Monday, the temperature was 4 degrees Celsius. Tuesday, 7 degrees Celsius. Wednesday, 3. Thursday, 1. Friday, 8. Actually, this must have been winter and very cold. I mean, the minimum temperature, it's 1, and the maximum is actually 8. 1 degrees is close to freezing. Even 8 is very cold. Okay. How do you draw a line graph for this? So to draw a line graph, we'll need a Cartesian plane, okay, with the y-axis as the temperature, on the x-axis Monday, Tuesday, Wednesday, Thursday, and Friday. Okay. What we're going to do is to put coordinates on the Cartesian plane. What do I mean coordinates? I mean, if you go back, if you look at Monday is 4 degrees Celsius, that will be a point, which is a coordinate. So for Monday, we have a point there, because Monday, the temperature is 4 degrees Celsius. What about Tuesday? We can put a point, which is 7. What about Wednesday? We have 3. And Thursday, we have 1 degrees. And Friday, do we have anything? For Friday, it's 8, which is the highest. Okay. Then from there, what we do to draw a line graph is just to connect, okay, with a line or a ruler. This is what we get. Okay. Why do we have a line graph? We can look at the trend. Okay. What does this tell us? We can see that from Tuesday to Thursday, what has been happening? The temperature has been decreasing. Okay. From Tuesday to Thursday. Okay. Great. So, I mean, we can use data to predict when you plan our holidays. If we have data for the past 2 years for an area, I can kind of predict the weather, okay, and plan for our holidays. Okay, guys, so hope to see you now after the break with more data representation. Fantastic. Welcome back once again. So we looked at different ways of representing data, okay? I mean, we looked at frequency table, pie chart, step and leave, histogram, and a line graph, okay? So representing data, we're making that visual to us. Having raw data does not really make any sense. So it's better to represent data. Okay, fantastic. So what we did, we looked at the bar graph, we looked at the pie chart, we looked at the stem and leaf, okay, remember that, and line graph, we just looked at that. Now we're going to look at what is correlation, okay, okay. What is that correlation actually, okay? So if you've been following what is happening with the COVID, with the pandemic, I mean, and how many people actually died from the COVID-19. So usually they will say if you're overweight, okay, elderly, so there's kind of correlation between dying from the COVID if you overage or obesity, okay. But how do they know that? Because we don't know the virus. It was based on data collected that, oh, this is the trend we see. because this is unknown. By using data, we can study even the virus we don't know by simple using data. Let's see what does it mean. Okay. So there are situations where people wish to find out whether two or more variables are related to each other. Okay. So we want to know whether two variables are related to each other. That's one way. COVID and age, based on data. I'm not sure scientific we have, but just because of data, they'll collect data. People die from COVID, they have their age. So suddenly we can actually say, oh, elderly, stay at home. If you have an underlying disease, look it after yourself or work from home, because there's some correlation. Okay. Because initially it was based on data. Now let's look at some of the correlation. Is symptomatic blood pressure related to age? It's a question. Having data, we're able to answer that question. Okay. This is some of the questions we can answer using data. What about, is the life expectancy of people in the country related to the wealth? Do we know that? Okay. If you look at a country during this pandemic, I mean, we have a country where the COVID actually killed more people in that country. That country, they have a health care for the elderly. So people live longer in that country. But because of the pandemic, the COVID was targeting all the people, lots of people died in that country. So yes, with data, we're able to answer the question. So that's one of the importance of having data. Let's look at something we can study using data. Results, your results are related to numbers of hours students spend undertaking part-time. I doubt, maybe because you're working part-time, you don't have time to study. We really don't know. I mean, we cannot really conclude without data also. Okay, so if you have data, one can really answer the question. Okay. Okay, so now it's an athlete leg length related to the time in which they can run 100 meters. I mean, this statement is saying, if you're taller, does it mean I'll run faster? Is that really true? I mean, we cannot really answer that question. I mean, I doubt it's true, but with data, you can answer the question, but does data really tell the truth? Not all the time. I mean, we really have to have arguments about it, but if you have data, you have some evidence for your argument. Okay, fantastic. So, correlation is a measure of relationship. The stronger the correlation, the more closely the related variables are likely to be. Okay. So we're not going to measure correlation. Okay. But does it mean, for example, I mean, if interest rates goes high, you have less money in your pocket. Those two have negative correlation in a way. Okay. So maybe if you study hard, you can pass. Those two, yes, really correlated. Okay. So now we're going to look at the scatter plot. So we looked at the bar, we look at the pie, we look at stem and leaf, we look at the line graph, we look at the scatter plot. Okay. We're going to look at the scatter plot now. Okay. Which is similar to kind of line graph. The difference between the two, you'll see that line graph, if you remember line graph, we drew points and we connected all the points with a ruler or a freehand. Okay. Okay. But now a scatter plot is just a little bit different from a line graph. We'll talk about it after this. What is actually the difference between the line graph and the scatter plot? So let's look at this. So if we have a scatter graph are used to show whether there is a relationship between two sets of data. the relationship between the data can be described either. So if you look at this, we should have the y-axis there, and the x, y-axis, and the x, y. Okay. So if you look at this, we have the height of people and the shoe size. Does it mean if I'm taller, I'll wear a bigger shoe size? Okay, is the statement true? This is the data collected and plot on that Cartesian plane. If we look at the points, they are close together. Okay, if the points they are close together, there's some strong correlation. Okay, so if you look at this, there is some strong correlation, but there's not 100% certain that it means if I'm taller, I will have a bigger size of shoe. There is a strong relationship. It can be true, it can be false, but there's a strong relationship between the two. Okay. If you look at soup sale and temperature, if I sell soup related to temperature, does it mean people buy soup based on temperature? Maybe, but this is the data collected. And actually, if you look at this, you're getting a negative kind of graph, but the lines still close together. So it's actually negative correlation. What does it mean if one goes up, the other decreases? Can you think of something like that? Here we have soup sale and temperature. If one goes up, the other decreases. Because think about it, in summer, as the temperature increases, well, the sale of soup decreases. Think about this. What about winter, cold, and I sell soup because it's colder, then people buy it. Can you think of something that has a negative correlation? I think something like what? Inflation. What does inflation do? Remember, inflation, what does inflation do? If inflation goes up, the money in your pocket decreases. Does that make sense? Okay? Another way, if an interest rate from the bank, if interest rate increases, the money you have decreases because you have to pay more. So those two have negative correlation. Something else I can think with negative correlation, what about petrol price and oil? Actually, 50% of petrol is made out of oil. If the oil price, I'm not sure if you heard sometimes that if the oil price actually decreases, suddenly the petrol will decrease. I'm not sure if you heard that. Then suddenly the oil will increase and the petrol will increase. Okay. Fantastic. Now let's look at another one. What about shoe size and your income? Annual income is how much you make. Really? I don't think there's correlation by just looking, but maybe you can collect data and test that. If you look at the points they are scattered all over the place. They're not even close together here. So this is actually no correlation. There is no relationship between your shoe size and income. Can you think of something that has no correlation at all? What do you want to think about? How about the distance you walk and your results? Not really. There's no correlation between that. Okay? But there might be a correlation. If you sleep, you can study better in a way. Okay? Great, fantastic. So if you look at that, if we draw a line there, can you see that we get kind of a straight line which goes through most of the point, which is the positive correlation. Think of like a gradient. Then the next one will get kind of a line going down, which is negative correlation. And here we won't fit any curve because points are all over the point. There is no relationship. I mean, there's been some arguments about lockdown and how many cases. They said there's no relationship. because lockdown was meant to prepare us for the wave. And some said, there's no relationship, please remove the lockdown. Is there a correlation between how many COVID cases in the lockdown? Yes, I think there is a relationship between that. Okay, but someone can arrive at different argument. Okay, even if you have same data set. So now let's look at the scatter plot. So here we have size, which is a shoe size. So we have size 5, and the weight for this person is 65 kilogram, and size 12, 97, size 7, 68, size 10, 92, size 10, 78, size 9, which is 78, size 8, 76, size 11 of a shoe size, 88, size 6, 74, size 8, 80. So this is the data collected of a shoe size and your weight. Is there some correlation between shoe size and weight? I mean, if you look at the data set, even the first one, yes, I can have a small size. If you look at, actually here, if you look at 8, size 8, can have 8, 80. 9, which is actually higher than that, but have actually a bigger size. But does it mean, is that true? So we need to draw a scatter plot and see what kind of correlation we have. So let's draw the scatter plot. So on our x-axis, we have a shoe size there. On the y-axis, we have mass, which is in kilogram. This is what we're going to do. Size 5, which is there. Size 5, we're going to put size 5, 65. 65 is somewhere there. We don't need this. We don't need this. So size 5, we have 65, is between 70 and 75. We're done with that. Size 12, shoe size 12, we get 97. This is 12 there, 97, we put a point there, close to 100. Okay, then size 7, shoe size, the weight we got from a survey. Remember, you'll go out there, do a survey. When you do a survey, you go and ask, you have a questionnaire, you ask people, what is your weight, what is your shoe size, and you record the data, then you plot that. Okay, that's from a survey. Now we have 7. 7 give us 68. 68, somewhere there, close to 70. Size 10, we get 95. Size 10, we get 95. Size 10, size 9, this size 9, we get 78. 78, which is close to 80 there. There's the point. Size 10, not size 10, I go to size 8. Size 8, and the weight is 78. Size 8, weight is 78. 78 is close to 80. There's the point there. Then size 11, the weight is 88. 11, on my x-axis, then I'm going to read 88, which is close to 90. Somewhere there, there's the point. And size 6, which is 74, size 6, which is 74, which is the point there. Then size 8, which is 80, size 8, which is 80, there. Then if you look at the points, they are kind of close together. What can we conclude about this? I think the line, I can fit a line like that, going up with a positive slope. So there is a positive correlation, slightly positive correlation, okay? This is not 100% certain, okay? But sometimes don't confuse something called causation and correlation. I mean, let's say lots of people drown at the beach and the sale of ice cream is high. Can we say ice cream causes drowning? No. It's important when you collect data, you have to interrogate what you're collecting. Okay? We cannot say that ice cream caused drowning because on that day lots of people drowned and the sale of ice cream was high. That's not really true. Okay? I hope this makes sense. This is a positive correlation. So what are we going to do now? If you look at our summary, we looked at what? The frequency. Frequency table is in the table form where you can collect your data and group everything. If you've been following the stats of COVID-19, has been recorded more into kind of frequency table with age, how many people with cases, and so on. That's kind of a frequency table. Stem and leave, we've seen stem and leave, you have a stem, there you leave. Okay, I've not seen that, maybe in the media or other way, unless in the books. I'm not sure why people are not using the stem and leave to represent data. Maybe it's not really that sufficient. Okay. Bar graph, I've seen quite a lot. Okay. Representing data, pie chart, I've seen. You can represent pie chart by representing the demographic in South Africa. You can use the pie chart to represent that. Line graph, I've seen a lot. Okay. Also in stock market, people use the line graph to kind of forecast and so on. Hope, guys, you enjoyed today. What I would encourage when you work on your mathematics is consistency and rigor. You don't just look at your math textbook. You do the problem with a pen and paper. That's how you do the mathematics. I hope you enjoyed the lesson. Keep working hard and be consistent. Anything is possible. Hope to see you soon.